Hi, this is Adam from AMF Tutoring. If you like this and other videos of mine, please go ahead and hit that subscribe and like button so you can keep up with my new and updated videos in the future. Now, today I wanted to talk about radicals and how to simplify those radicals. Now, radical is something that has a symbol that looks like this. Almost looks like a division sign, but it's a radical symbol. Within each radical symbol, there is what is called an index. So, for instance, this 3 here is called an index. This symbol, no number written, this is a square root symbol. There is an index on this too. We don't usually write it, but we could write a 2 there, and that would be its index. Now, I'm sure many of you know that the square root of 9 is equal to 3. Now, a square root symbol with an index of 2 tells me I'm looking for 2 of the same factor inside the radical symbol. Okay, so I could rewrite 9. I could rewrite that number 9. I could say square root of 3 times 3. Right? This index of 2 tells me I'm looking for 2 of the same factor. So I have 2 3's inside my radical symbol, and they can come outside the radical symbol and just give me a single 3. So 2 3's inside the square root sign becomes just a single 3 outside the square root sign. Similar thing for this cube root of 8. This index tells me how many of the same factor I'm looking for. Okay, so I could rewrite this instead of 8 there. Well, 8 is the same as 2 times 2 times 2. Right? 2 times 2 is 4, times another 2 is 8. So 8 can be rewritten as 2 times 2 times 2. Since we have a cube root this time, we have 3 of the same factor, which means the cube root of 8 gives me a 2. Right? 3 factors of 2 inside the cube root becomes a single 2 outside the cube root sign. Now let's take a look at a couple of just more involved examples where we are going to simplify these radicals. Okay, so the first one, we have square root of 18. Now the square root, like we just saw, means we're looking for 2 of the same factor. All right, so what I like to do with these is take that 18 and I make a factor tree out of it to help me out. Let's see, what numbers multiply to give me 18? Um, well, we could say 6 and 3 would work, right? Now, 3 cannot be broken down anymore, but this 6 can. I can break down that 6 into, let's see, 2 times 3. Okay, so instead of writing this as square root of 18, I could use the ends of these branches to rewrite that expression. Instead of square root 18, I could say square root of 2 times 3 times 3. Okay, so I rewrite square root 18 into square root of 2 times 3 times 3. Now we're looking for pairs or 2 of the same factor. So in this case, I have 2 3's. So 2 3's that are inside my square root sign will come outside the square root. Anything unpaired will stay inside. So that 2 is unpaired. There's no other factors of 2, so that's going to stay inside. So my final simplified expression here is 3 times the square root of 2. 2 factors of 3 inside becomes a single factor of 3 outside. This unpaired 2 stays inside. Similarly, for the cube root of 40, we're going to do the same thing. We'll make a factor tree, but we're going to look for 3 of the same factor that we can pull outside. Right. So let's see, what numbers multiply to give me 40? Well, I think 4 and 10 would work. Right? 4 times 10 is 40. 4 I can break down. Let's see, 4, that's 2 times 2. Those can't be broken down more, but the 10 can be broken down. 10 can be Is that 2 and 5? 2 times 5 gives me 10. And neither of those numbers can be broken down. So we're at the ends of all the branches of this tree. So instead of cube root of 40, I could rewrite as cube root of the ends of all my branches. 2 times 2 times 2, extend that a bit, times a 5. Okay. Like I said, cube root, so we look for 3 of the same factor. In this case, we have 3 2's. Right? 3 2's inside the cube root becomes a single 2 outside the cube root. Anything not in 3's will stay inside, so the 5 will stay inside. So cube root of 40, if we simplify that, that's cube root, or excuse me, 2 times the cube root of 5. Okay? Now, it doesn't have to be just square root or cube root, right? We could continue this idea. We could have something like fourth root of something, in which case we would be looking for 4 of the same number, or fifth root of something. Again, looking for 5 of the same number. So it doesn't matter what index, as long as we're looking for that amount of factors, that amount of the same factor inside that we can pull outside. Okay, I hope this video was helpful for you in understanding how to evaluate and simplify some radicals. Again, be sure to hit that subscribe button to stay up to date with my videos. Until next time, bye.